Usually the last part of teaching solving equations that I do with algebra students is taking a problem that has multiple variables in it and then solving for one variable or another. And that's what this is today, okay? So we're reviewing that. The volume of a cylinder is given by the formula. Probably would be good if I had my pens working. Hold on. It's given by the formula pi r squared h, where r is the radius and h is the height of the cylinder. The formula gives volume in terms of r and h. If you have the values of r and h, you can use it to find v. Okay? But sometimes maybe you have v in r but not h. You want to solve for h instead. So that's what we're going to be doing here. So here's our first example. Just in case, that's kind of punny, just in case, is an engineer for a barrel manufacturing company. He wants to design a cylindrical barrel to contain 500,000 centimeters cubed of liquid and is considering several different radii and heights. To do this, it is useful to solve for the volume in terms of for h in terms of r. So we're really trying to solve for h. And one of the things I tell everyone when they're doing this is circle the one that you're trying to solve for. Okay? What is happening outside of that h? We have a pi and we have an r squared that's being multiplied to it. So what we really want to do is move that away from h. And in order to undo a multiply, we are going to divide. So I'm going to divide both sides by pi r squared. Okay? When I do that, these cancel on this side. So I now have v over pi r squared equals h. Part B says find the height of the barrel with a radius of 30 and that will contain 500,000 centimeters cubed of liquid. So we're going to replace our V, our volume, with 500,000. And we're going to divide that by pi times 30, and we're going to square that 30. So if you put that in your calculator, it'll come close to, it's going to be rounded a little bit, 176.8 centimeters should be the height. So, for example 1b, the period of a pendulum is the time in seconds that it takes the pendulum to make one complete swing back and forth. It is calculated by using this formula, where L is the length of the pendulum in meters, and G is the acceleration due to gravity, 9.8 meters per second squared. So in this one, they want us to solve for L. So once again, I want to tell you guys, circle what you're solving for. In this case, it's L. So looking at this is going to take more than one step. You can think of the square root as a grouping symbol. What's happening outside of that square root that I can get rid of right away? The 2 pi. And it's being multiplied to that side. So to undo a multiply, I'm going to divide both sides by 2 pi. So that I can cancel that out right there. Now I have p over 2 pi equals the square root of L over G. How do you get rid of a square root? Yeah, you square both sides. Yep. So I'm going to square this side and this side. Now I have p squared, and what is 2 squared? 4, and then we have pi squared next to that, equals L over G. So we're almost done, not quite. Remember, we're solving for L. How do I get rid of that G? Very good. So I'm going to times both sides by G. Oops. Okay. So now my final answer is L equals G times P squared over 4 pi squared. So part B asks, what is the approximate length of the pendulum whose period is 1 minute? We already know that our G is 9.8. Okay, so I'm going to say L equals 9.8 times 1 squared over 4 times pi squared. Okay, if you were to put that in your calculator, and don't forget to square the pi, it's about 893.65 meters. It's a long pendulum. Okay, went too fast when I was doing this earlier, so this should be 60 seconds because it's in. This is a minute, so you got to convert that to seconds. Yep, thank you. All right, so let's look at the next problem. I want to give you guys a second to see if you can actually do problem 2A on your own. And in this case, you're solving for T. Okay, so see if you can go through this formula and solve for T by yourself. Oops. All right, so we're solving for T. For some reason, it's still frozen. There we go. So remember, so if you circle, that's what you're solving for. I need to get everything away from it, and we can think of this as a group right there. So if I need to get that out of the denominator, I'm going to multiply both sides by r minus 65. Okay, so this will cancel. And then I will have r minus 65 times c equals 65t. Get t by itself, I'm going to divide both sides by 65. So then t is by itself there. Okay, so we have, because of density of air is consumed by scuba divers, it increases as they dive deeper. They consume more air the deeper they dive. We have this formula, and it is used by some scuba divers to estimate the number of minutes of air they will have at a depth D in seawater. If they consume a tank of air at the surface in S minutes, solve the formula for D in terms of T and S. Okay, so we're looking to solve this formula right here. T equals 30S over D plus 30. And we want to solve for D this time. So I'm going to give you a minute to think about that one. See if you can do it. Just like last time, this time we have this whole thing in the denominator. Okay, and even though we're solving for D, we still need to get rid of the denominator so we can get D by itself. So I'm going to multiply this entire thing by D plus 30. Okay, by doing that I get rid of this, And now I have D plus 30T equals 30S. Yes? There you go. Okay, so we could distribute this T, but that's actually adding a lot more time to what we got to do. We need to get D by itself. So the first thing I want to do is get everything on the outside of this quantity away from D. It's being multiplied by T, so how do I get rid of that? Yes?
Oh, sorry.
Okay. So I'm going to divide both sides by T. Okay? So now I have D plus 30 equals 30S over T. Subtract 30 from both sides, and then I'll have D by itself. So part 3A says solve V for R. So I want you to try that one now. Solve for R. So my goal here is to get everything away from the R. I got a pi and an h. So I'm going to divide both sides by pi h first of all. Okay? The pi will cancel and the h will cancel. So now I have r squared equals v divided by pi h. I have an r squared. So what's the way I get rid of a squared? Square root both sides. Okay? So then I have r equals square root of v over pi h. So part B really is just replacing the variables with the numbers here. Okay? So assume a fixed volume. It doesn't tell us what h is though, so we're just going to replace the v with 500,000 over pi h, and it's going to be square root. So that is all you do for part B. (3B). We have V equals 1/3 BH, and we're trying to solve for H. So if I'm trying to solve for H and I want to get rid of the 1/3, how do I do that? Multiply each side by 3. So that's the first thing I would do. So 3V equals big B H. Divide both sides by B. So my final answer on this would be 3V over base equals H. Part B wants us to use 231 meters as one side of the base. It's a square base. It's a square pyramid. So how do I find B? What's the area of the base? So we're going to have 3 times the volume on the top. And then for the base, it's 231 squared. So you should have got, if you put that in your calculator, 147. Okay, that's in meters.